Imagine a candy store paying you to think smarter. You can buy 2 candies and get 1 free, but can you maximize the discount? One simple greedy trick turns this into an easy leak-toed solution. Want full solution? Check this video.
Hi everyone and welcome back. Have you ever seen a greedy problem that looks tricky at first, but it turns out that we can have a very simple solution at the end? Today, we are solving the lead code problem, minimum cost of buying candies with discount. A shop is selling candies at a discount. For every 2 candies sold, the shop gives the third candy for free. So the customer can choose any candy to take away for free as long as the cost of the chosen candy is less than or equal to the minimum cost of the 2 candies bought. For example, if we have 4 candies with the cost 1, 2, 3, and 4, and the customer buys candies with cost 2 and 3, then he can take the candy with the cost 1 for free, but not the candy with cost 4. So here is the deal. Every time we buy 3 candies, the cheapest one among those 3 candies becomes free. So our goal here is to maximize is to minimize the total amount of money we spent. So we need to return the minimum cost of buying all the candies. So let's understand the key insight. Suppose we have candies with cost, for example, if we have candies with cost, let's say 6 and 5 and 4, if we buy all 3 together, we pay for the candy with the cost 6 and the candy with the cost 5, and the candy with the cost 4 is free. So imagine if we have the costs looks like 10, 9, 8, 7, 6, and 5. So how we should group all of these candies in a way that we can then, when we process the candies, we can get the minimum cost of buying all the candies. The most important observation in this is that we want the free candies to be as expensive as possible, because every free candy directly reduces the amount we pay. So how do we maximize the value of the free candy? Simple. We need to sort all the candies in descending order from the greatest cost to the smallest cost, and then after sorting, the largest or the most expensive candies appears first. Now, if we process the candies in a group of 3, then for every group we pay for the first candy and the second candy, and then we get the third candy for free. Maybe you may wonder, why does this works? Because after sorting, each third candy is the largest possible candy that can be legally free. Any other arrangement would only make the free candy cheaper, which would increase the final cost. So let's walk through an example to test our criteria here. So suppose we have the cost of candy looks like 6, 5, 7, 9, 2, 2. So first we need to sort the cost of the candy in descending order. So it will look like 9, 7, 6, 5, and then 2 and 2. And after that, we create groups of 3. So in this case, we will pay, so the cost will be 9 plus 7, and we will take the third candy for free, and the second group will be 5, 2, 2. So we will pay for the first one, which is 5, and the second one in this group, which is 2, and we will get the third candy of cost 2 for free. And that will give us a total cost of 23. And this is exactly what we want. So let's go to the implementation. First, we need to sort the array. So we will sort the array. We give it the bean iterator and the end iterator. And remember, we need to sort the array in the descending order. So and we will define two variables, one that will hold the final answer, and we will define variable n that will hold the size of the cost array. And after that, we will iterate through the array 3 elements at a time. So for int I equal 0 and I is less than n and I plus equal 3. So our I index will jump by 3 elements. And after that, we will add the cost of the first element in the group. So we will add the cost of I, and then we will check if I plus 1 still within the boundary of the array, and if yes, we will add the second element in the group to the answer. So we will add the cost of I plus 1, and we will iterate again and incrementing our I variable with number 3. That means we will skip the third element in the group because it's a free candy, and at the end we will return our answer. So let's run it to make sure we don't have any syntax error. Let's submit it. And as you can see, this is the most optimal solution for this problem in terms of time complexity. The time complexity here is O of n log n, and this is because of the sorting here. And the transversal itself is O of n. And for space complexity, it's O of 1 because we didn't use any extra memory. So this is a classic gritty problem. The trick here is realizing that to maximize the discount, we should sort the candy from the largest element or the largest cost to the smallest cost and make every third candy free. And that's it for today's problem. If this explanation helped you understand the greedy insight, don't forget to like the video and subscribe to the channel for more lead code solution and code interview preparation. See you in next video. Bye.